Hello, everyone. Just going to make a couple videos here to go over the STAT 145 final exam review sheet. This video will include your Mini-TAP steps. So let's start with problem number one. Problem number one is a hypothesis test. It says many consumers have no cola preference. Maybe I would argue that, but anyways, the Pepsi company would like to convince others that more than 50% of consumers prefer Pepsi over cola, like over Coke. Just reading this problem here. Oh, that's blurry. Okay. A random sample of 100 consumers tasted 2 colas, 56 preferred the Pepsi. So we want to know, does the sample provide evidence to say that it's more than 50%? So let's go ahead and get started. This is a full hypothesis test. You have all 5 steps for this process. So we're going to go ahead and start right with the population step. And we're going to identify the objects. Now, the objects here are who we're sampling or who we're giving the survey to. And this is just going to be people in general. You could say consumers if you want. The variable is the next thing we want to identify. The variable is what are we asking them? Okay, so this is categorical, right? Because it's a taste test. Do you prefer it or not? So it's a yes, no. Trying to focus my camera a little bit. So I'm just going to say, do they prefer Pepsi? Because that's what we're really looking at. This is a yes, no, this is categorical. Okay. Next is my unknown, and my unknown here is my population proportion. So it's going to be P. P is the population proportion of people who prefer Pepsi. Okay. Next is my goal. Now, sometimes we come back to the goal after we write our null and alternative. We can do that, but we don't have to do that. We can just go ahead and write the goal. It's kind of something. Sorry, it's kind of something. I'm just going to clean this. I apologize. See if that helps at all. I don't know why it's so blurry. Wow. Okay, maybe that's a little better. Something that you're kind of just get used to doing, and it might not be, just a smooth transition just yet because you guys are new at this, and that's okay. So I'm just going to go down to the method because then I'm going to show you what we're going to write. So for my method step, we identify the null, alternative, alpha, and what curve I'm on. So I always write my alternative first. This is what we're trying to show. So we're trying to show that P is greater than 0.5, right? Greater than the 50%. This always matches what the researcher is trying to show. So my null is going to be P is equal to 0.5. But my HA is what I'm writing for my goal. I'm just going to write it on words, which I've already defined P up here. So I'll just write to say that the population proportion of people who prefer Pepsi is greater than 50%. Okay, so now that's my goal. So now I'm going to go ahead down to alpha. Alpha was given to me in the problem. It says 5% level of significance. So this is 0.05, 5%. And what curve I'm on depends on what type of data I'm looking at, categorical data or categorical variable. So here I'm on the Z curve. Now, after this point, I can move on to my sample step. So the sample step, remember, is real simple. This is the step where I'm going to just look at the information that's given to me in the problem and pull out the information about the sample. So here for my sample step, when it's categorical, I'm going to identify X N, calculate P hat, and check for normality. So X is the number of individuals with a characteristic. So it's the number of individuals in this study who said yes, that they prefer Pepsi, and it said it's 56 people said that. N is just my sample size, and we were given that we sampled 100 individuals. P hat is just going to be X over N, which is 56 divided by 100, or 0.56. And then normality, it's N times P times 1 minus P is greater than or equal to 10. Now remember, you have to choose which value of P to plug in here. It's P naught, right? It's always the center of my curve. P naught is the 0.5, it's the value from my null. So I'm just going to plug in the values just to show you. So you have it down here. That's what we're looking at, okay? So yes, 25 is greater than 10. So I'm just going to say yes, normal. Just like that. Okay. And that completes my sample step. So now let's move on to the result step. The result step is where we will need to use Minitab. And here we're going to calculate the z-test statistic. Remember, you can do this by hand or use Minitab. I will show you the Minitab way. We're going to interpret the value. We will find the p-value, which we're going to use Minitab for that as well. And we're going to interpret that p-value. So I'm going to go ahead and open up a Minitab and share that with you, and we can take a look at this together. Okay, so if we're in Minitab here, I just have a blank screen. There's nothing going on right here. I don't have any raw data, and that's okay. I don't need it. So I'm going to choose stat basic, and this is proportions, and it's one sample, so it's one proportion. If it was numerical, you would do one sample T. Okay, so one proportion for our one sample of categorical data. We have summarized data. Number of events is X, that's 56. Number of trials is N, that is 100. I'm going to perform a hypothesis test. I need to enter here what my null is, it's 0.50. I'm going to choose options. Under options, my confidence level is only for a CI. We're not calculating CI, so I'm just going to leave it. It doesn't matter. My alternative hypothesis has to match my HA. My HA is the greater than. I'm going to change it there. My method, we check for normality. We're always going to use that normal approximation. Remember, this is the same Minitab feature used for a CI as well. All right, so I'm going to click OK twice, and we'll take a look at our output. So here's my output that I'm interested in. There's my Z, 1.20, and my P is 0.115. Okay, so let's go back over here, and we can take a look. So this is 1.20, and this is 0.115. So I'm going to interpret this. I'm just going to say my p hat, or you could say my sample proportion, doesn't matter, is 1.20 standard errors above, because it's a positive value, my center, and my center is 0.50. Now here's my p-value is 0.115. So that's the probability it's going to happen again, right? So I just want to write that down. So if the population proportion is 0.5, right? So if the center is really the center, if it's 0.5, that's how we calculate this probability. There is a 0.115 probability of getting a sample proportion at least as extreme as the one we got from sampling. And that completes my result step. Now, after my results step, I can move on to my conclusion. This is the last step of my 5-step process. This is where we're going to pull all of this together and make a conclusion about what's going on with that population. So my conclusion, I always start the same way, is my p-value. So it is 0.115 less than or equal to 0.05. If you have a hard time with decimals, convert it to percentages. So it was 11.5% less than 5%. No, that means we cannot reject. Remember, it's all negatives or all positive. So we cannot reject the null. So that means we cannot say that the HA is true. So I'm going to write that. So tried to combine two words there. So at the 5% level of significance, we cannot conclude, and I'm just going to write my goal here. Conclude, I'm just going to look at my goal up here and see what I have. That the population proportion of people who prefer Pepsi is greater than 50%. Okay. So we're just going to accept right now that it is 50%. We can't say that it's more than that. Okay. The sample does not provide evidence to say that. And that's my full hypothesis test. All right, let's take a look at question number 2. Oh, this is some probability. So question number 2, we're looking at seafood products. Okay, so we're looking at where people live and if they like, dislike, or if they're uncertain about clam chowder. Okay, so we have this two-way table. So I typically use the two-way table and not the formulas. You can use either method. It doesn't matter to me. So part A, what is the probability that a person in the study is from the Northeast and likes the clam chowder? So I'm going to write my notation. So it's probability that they're from the Northeast and likes the clam chowder. So now I'm going to go over here. Sorry, my thing has been used, so it's hard to see a little bit, but you can kind of follow along what I'm going to look at here. So I'm looking at the cross section, right? And means it has both. So Northeast is this top row and like is the first column. So you can see it's 30 or in that one space out of the total of 240. So this is just 30 out of 240. All right, let's take a look at part B. So what is the probability a person in the study likes the clam chowder? Okay, so it's just a single probability. There's no combination of two things. It's just the probability of likes. I was kind of reading it again, thinking that there's gonna be more to it. So probability of likes, remember like just what we just looked at is this first column. So it's 80 individuals out of the table total of 240. And that's it. You don't have to reduce your fractions for me. I actually prefer them like this, then everyone kind of has similar answers. All right, or hopefully they do if they get it wrong, right? I mean, so what is the probability that a person in the study is from the Northeast or likes? Okay, so probability from the Northeast or likes. Okay, or means you could be Northeast, you could be like, or you could be the combination Northeast like. But remember, since they cross, when you're using a formula, you always have to subtract out where they cross because you double count those individuals. If you're doing the table with the shading, you don't have to worry about it. You only count that that box of those individuals at the cross once anyways. So again, we're still looking at that top row, Northeast, first column, likes. So I'm going to add all these numbers up. So the top row, we could see the total is 60, and then I'm going to add, it looks like 10 and 40 to it. Do you see? So you have 15, 15, 30, 10, 40. Like you only add that 30 one time. Okay. So it's 60 plus 50. So I have 110 out of the 240. All right, then I'm going to look at the next one. So what is the probability, I'm sorry, if a person in the study is from the West, what's the probability that they like the clam chowder? So probability that they like given they're from the West, okay? So this is my conditional probability. So here, given that they're from the West, you could see here it's in red outline already because I already did this before. So my red outline here, and it's just the probability that they like. So it's 40 out of that total of 120. So when I say that total, I'm talking about the total for just the West, my restriction, that 120. So 40 out of 120. Then in part E, it says, which of the following events are mutually exclusive or disjoint? That means that there's no overlap. Okay, so it's multiple choice. It says uncertain and dislike, like, southeast, west, and like, uncertain and west. So remember, disjoint, no overlap, or mutually exclusive, all of those mean the same thing. And all it means is that we're looking at two events. Remember, like is an event, dislike's an event, uncertain is an event. Okay, each individual thing's an event. And we're looking for something that does not cross, does not overlap. So it could be any two of the likes, dislikes, or uncertain, or any two of the regions. Okay, so when it's the only one here has uncertain and dislike. Okay, so that is A for that one. All right, let's take a look at number 3. So number 3, we're looking at a cola machine in a cafeteria. Okay, and it's set up to serve a standard amount of cola. An employee wonders what's the average amount of cola that is served. So this is like a quality control issue, right? So they obtain random samples, 61 random samples. I'm sorry, 61 is in my random sample, if I didn't say that clearly enough. And from the machine, they found that the average is 8.7 and the standard deviation is 0.49. So I'm just going to write that down, that my X bar is 8.7 and my standard deviation from my sample is 0.49. And then I'm also going to write down N, which was 61. This is all important information. Part A says estimate right away. I see the word estimate. That means confidence interval. So it's chapter 9. So estimate the mean amount. So I have my sample. I now want to estimate my population. So I'm trying to estimate mu. So we can do this by hand or use Minitab. Remember, this is going to be X bar plus or minus my T at alpha divided by 2 because it is numerical, times my standard error. Standard error is S divided by square root of N. That's my formula. But remember, Minitab will do this for me, so I don't actually have to do this by hand. If I gave Minitab these 3 numbers, I can ask for it. So let's go ahead and do that. So I'm going to go over to Minitab, the same feature I was just in, and that's okay. Not the feature, but the same Minitab is open from before. So stat basic 1 sample T. Now this is the same feature you would use if you were looking at a hypothesis test. 1 sample T because I have 1 sample of numerical data. So I have summarized data, sample size 61, sample mean 8.7, and standard deviation is 0.49. I'm not performing a hypothesis test, but I am going to choose options. I want to make sure my confidence level is correct. It says with 95% confidence. Remember that defaults here, and that's what I'm looking for. Also, the not equals defaults, and I always want the not equals for the CI. All right, so I'm just going to click OK twice, and right here is my CI. So we can see that the CI is 8.5745 up to 8.8255. Okay. So I believe that's probably ounces. All right, I'm just going to go back here to the paper. All right. So here is my CI. This answers the question for part A. Now in part B, it wants you to kind of dissect this. It wants to know, what is your point estimate And what is your margin of error? So if you're looking at point estimate, that is this. This is point estimate. Okay. This whole side here is the margin of error. So if you did this calculation by hand in part A, you'd easily have those numbers. If not, you can easily get them from the CI. So point estimate, the midpoint, but it's X bar. We already have X bar. So I'm just going to say point estimate is equal to 8.7. Then margin of error here, it's my t value times s divided by square root of n. But what I also want you to think about is that it's just the distance. So you could just take a calculator and you could say 8.825 minus 8.7. Okay. So you can take 8.7 minus 8.5. It's just the distance from the midpoint, the middle of the CI, to one of the endpoints. So it doesn't matter. So when I get that, I get 0.125. That's my margin of error. Now, probably the most important part of this problem, besides getting the numbers, is being able to interpret the numbers, being able to put this into words, okay, what this means. So I'm just going to use our generic. We are 95% confident that the population mean amount of cola served is between this 8.5745 and 8.825. That's it. And it's probably ounces. I should just say ounces. I'm sure that's what it is. Okay. This is important. It's important to have your confidence level. It's important for you to have the word population mean. Okay. This means that it's the average of all of the servings, not just the sample, right? It's just we're basing it on the sample. All right. And then, of course, the who and the what. So the amount of cola being served, right? So that's what's also important. And then, of course, my low and profound. Now, part D has a follow-up question here. The machine is supposed to serve 9 ounces, but some employees think that it's serving less than 9, which it probably is, because if you look at our CI and our sample, 8.7, right? But it's not based on the sample, it's based on the CI itself. So we want to know, can we confirm that it's less than 9 ounces based on the CI? So based on these numbers here, can we say that the machine is serving less? Yes, we can. So it's going to be yes, since the entire CI is less than 9. That's it. Right? So remember, greater than or less than statement, it just means that the entire CI is greater than or less than that number, right? Whatever it says. If it's an equal to, you're looking for whatever you're interested in to be inside. Okay. This is a less than, so I'm looking for the whole CI to be less than that number. All right. And then part E. Oh, we have 2 more parts. Part E. If we obtained 100 random samples of 50 servings from this machine, and we computed 95 CIs, 95% CI for each sample, we would expect how many of those CIs to contain the population mean amount. It's just my CI level, so it would just be 95, since I have 95% confidence. If I had 85% confidence, it'd be 85 of those CIs would have that. If it was 90, it'd be 90. That's it. All right. And then F, if the confidence level is reduced to 90, how does this affect my CI? So remember, if we're looking at confidence, it's the wider is the larger confidence. And then it becomes more narrow. Okay. Smaller. A smaller interval would be less confidence. So if we are at 95, we're going down to 90. That means we're going to have a more narrow. So that would be answer D. All right. let's take a look at number 4. So, manufacturer of tires has a mean. So X bar is 50,000. And my standard deviation, S, is 6,000. It says draw a picture of the empirical rule. Okay, so we're going to be using the empirical rule. So no mini tab required here at all. And then we're going to just estimate some values based on the empirical rule. Remember, my empirical rule comes right from the center being my X bar. So that is my 50,000 here. Then I'm going to add one standard deviation. So that's a 6,000. So we have 56,000. I'm going to add another 6,000. So I have 62,000. Okay. And then you can add one more 6,000 to that one. So you have 68,000. I'm going to do the same thing on the left side by subtracting. Okay. Now I want to fill this in with some percentages so I can just read it and be real quick with everything. So here my percentages, I start with 0.15%, then I go to 2.35%, 13.5%, 34%, and then it's the same on the other side, 34, 13.5, 2.35, and 0.15%. Okay. That's what we're looking at. All right. If we were looking at the center, remember this is 68. Then the next one is 95. And then the last here is 99.7% of our data falls in there. Okay, let's go ahead and answer some questions. So this was part A. So part B, what is the percentage of tires that will last between 38 and 62? So I'm looking at here and here, and well, all I'm going to do is between 38 and 62, I can add up all the percentages, or I can notice, hey, this is like a center, right? It's like the same, it's this 95 here. So it's approximately 95%, okay? If you just said 95%, that's good. Oops, C, not A. So C, what percentage of tires will last less than 44,000 miles? So we're at 44,000 here, less than is to the left. I'm at 44, I'm going to add up all the values, 13.5, 2.35, 0.15, and I get 16%. And then the next one, 2.5% of all the tires will last longer than 62,000 miles. So we're here at 62,000, longer would be more than. So I'm at 62, I'm going to add up the 2.35 and the 0.15 here. Oh, I'm sorry. It gave me the percentage. I totally read that wrong. So 2.5% will last longer. Okay, so if it says longer more than, you know, you're on the right, and I'm going to start adding these percentages up to get to the 2.5. So here I am, and that leaves you to the 62,000. Totally read that one backwards. Okay, and then we have part E. So so Daisy driver bought tires for a car. Tires had a lifetime of 36. I'm just gonna write this down. 780. So 36,780 miles. Would you consider the lifetime to be unusually low? Remember, anything unusual is outside plus or minus 2 standard deviations from the mean, right? So anything that's unusual, 2 standard deviations, is outside 2 standard deviations away. So this is 36,000. Yeah, look at 38,000 as the cutoff. Anything below 38,000 would be unusually low. So I'm going to say yes. Okay. And just say it is more than 2 standard deviations below the mean. Or you could say 60,000, anything like that. Okay. And that is number 4. Okay, let's take a look at number 5 here. So number 5, we're going to look at regression. So we have the growth of fish. So they're placed in tank immediately after birth, and we're going to look at the age and days and the length in Okay, so I am going to, while we're just chatting for a second, I'm going to type this information into Minitab. And I'll actually just share this screen and then you can see what I'm typing in. And then I'm going to use this to find my correlation and run my regression model. So I should have had this ready. I did not think about it. So one thing I would suggest, if you guys are doing this kind of thing where you're plugging raw data into Minitab, I would type it in and then double check. Make sure you typed all your values in correctly. And then you kind of feel confident what's going on. All right. I'm typing everything in right. Now, also another thing that could happen, if you accidentally hit a key that is a letter and not a number, Minitab does not like that. And it's in the column, it will change that column from numerical to categorical. Like it will look like it's text. In my suggestion, in that case, I would just start over, either by opening a whole new Minitab and typing your information in again, or I would just start typing in 2 new columns and just start over. So what would happen if that was the case? You would see a T show up next to like C2 or C1, if that was the case, and then it won't let you do what you need to do. Okay, so here it wants me to get my correlation value. So remember that one's in the odd place. So stat basic correlation. Just going to bring both of them in. Okay, age is X, length is Y, and click OK. Now we can get our graph here, which is already provided on the paper for us. But what we're looking at is this. So for part A, it says, what is your correlation value? So R is 0.864. It says, oh, I'm kind of skipping past that other part. What does your value correlation indicate about the strength and direction? So all I'm going to say here, I know you guys can still see my screen, so or my paper here. So 0.864 is pretty close to +1. I would say this is a strong linear relationship. Remember, R only measures linear relationship. So I'm going to just write it in context. So there is a strong positive linear relationship. Whoa, throwing my pen here. Between age of a fish and length. Okay. And that's how I would write up my interpretation of the value R. All right, so now let's know in part B, what is my equation? So here I'm going to go back to Minitab. So stat, regression, regression again, fit my regression model. Response is my Y, so this is the length. And contiguous predictor is age, that is my X. So I'm just going to click OK. I don't have to do anything fancy. My equation is right up here on the top. So you can write it out like that, or you could say Y hat, either one. And you can write in the same order, or you could change your order. So Y hat equals 892 plus 2562 times X or times age. It doesn't matter how you write it. You know, as long as you write it correctly, that's okay. All right, then in part C, it says, write a sentence to interpret the slope. So to interpret the slope, just gonna kind of get out of this for a second. So to interpret the slope, what I want to do is I want to write about what happens to Y as this increases. So what I'm saying is if I plugged in 1 here, what happens to my Y? my Y will increase by 25, right? If I plug 2 in, then my Y is going to increase by a little over 51, right? Because I'm multiplying this by 2. So I'm just going to write that out. So for each day increase, because that's what we're talking about for age, the length increases, and that's because my slope is positive, by 25.62 UM. Okay. All right, that was pretty simple. Part D, for this data, what is the value of R squared? So I can actually take 0.864 and square that, or I can look in my model summary in my regression of Minitab, and I can see that I have R squared right there, which is 74.67%. And it wants me to interpret what this is. So in part, nope, the second part of this. So I have 74.67% of the variation, or you can say spread here. In fish length. And be explained by the line, or you could say the regression equation, or you can write the equation of the line. Any of those would be good. And then in part E here, what length would you predict? Predict means you're going to find y hat, so you're going to plug it into the equation for a fish who's 50 days old. So I'm just going to take my equation and plug it in, plug 50 into this here, and I find 2,172.88, okay, or 2,173. And that's it for question 5. All right, I'm going to take a quick break, and I will have a second video with the last 5 problems. Thanks, guys.